Alrighty, welcome back to another video, and in this one we are going to be taking a look at how to add long-term memory to your LLM chatbot. Now let me go ahead and give you an example of what the heck I'm talking about. So let's say talking to ChatGPT and I want it to, let's say, tell me a joke about pizza. Alright, so let's see what it comes up with. Why did the pizza apply for a job? Because it wanted to make some dough. Not bad. Okay. So funny joke. Now let's pretend I, take a step away from my computer, go grab a cup of water, come back, and okay, talking to ChatGPT again. Tell me that joke about pizza again. Man, I need a good laugh. Sure. Wait, what's this? Why didn't the slice? Because it couldn't. Okay, that's a pretty funny joke, but no, I wanted the joke that you told me last time. That was my favorite joke. Well, let me see. No, the one from last time. Okay, that must be able to clear it up. What type of? Okay, so clearly ChatGPT, or whatever I'm talking to right now, it has no recollection of our previous conversation. And honestly, it makes me feel a little bit hurt inside because it's like, yeah, we had this whole relationship going and now you're pretending like you don't even know about our past. And well, honestly, I just don't like feeling this way. So let's figure out how we can add some long-term memory to Aya. Give her a little bit improvement over ChatGPT. So how are we going to be doing this? Well, we are going to be using this little thingy called embeddings. So what are embeddings? Embeddings are how we can turn text into numbers. Okay, that sounds interesting. Not sure why we would want to do that, but let's go ahead and scroll down and see if we can figure this out. So first of all, how do we get these magical embeddings? Well, it looks like we use this function right here and we give it some text. And then after that, let's see what we get back. Okay. So it will contain the embedding vector along with some other data. And this embedding vector, it just looks like a big array of numbers. Okay, so indeed, these embeddings are a numerical representation of this text. Interesting, but then the question still remains, why do we want a big number that represents some text? Well, let's put that thought on the back burner for just a second and hop over and talk about space for just a little bit. So here, what we're looking at is one-dimensional space. We only have one axis, the x-axis. And if I were to say something like, let's find something at location 8, let's say. Let me get another shape here so we can have something to draw with. All right, just this red. I'll make this a red circle. It can be my little pointer, I guess. But let's say we wanted to just signify something at location 8. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So in one-dimensional space, 8, you just count over 8 spots. So let's, make this a little bit fancier. And now let's go to two-dimensional space. Well, now I can give you two coordinates like location 4, 8. So what we would do is count over 4 and then we would count up 8. So we have two axes, two coordinates. Okay, simple enough. Same thing with 3 dimensions. So if we have 3 dimensions, I could give you a 3 coordinate system, an X location, a Y location, and a Z location. Now, honestly, anything more than 3 dimensions, it's kind of hard for me to comprehend. However, thankfully, for computers, it's not. So what does all this have to do with vectors? Well, this vector representation right here, believe it or not, there are a lot more than these 4 numbers. In this embedding, there are like 1,500 right around there. I think it's like 15,000 or 1,567, whatever. This actually maps to, and I know this terminology is like not exactly right, but just to kind of lay down the concepts, this maps to a point in like 1,500 dimensional space. So basically, whenever you have a piece of text right here, at very high dimensional space, that can be converted to a point that's out there somewhere. Actually, let's say that some text is converted to this point in whatever dimensional space. And we'll say another bit of text is converted to this point in whatever dimensional space. All right, that's interesting. So I guess we're getting somewhere. We know that different text kind of aligns with different points in space, but I still don't see how this is going to help us with that long-term memory pizza problem we were talking about earlier. So check this out. Let me just go ahead and get rid of this. And now that we had our little side quest talking about space, let's go ahead and take a look at a more realistic example of what's going to happen. So in this example, instead of this text right here, I am going to be converting these little messages to vectors. So let's just go ahead and take this one real quick that says I love pizza, and we'll kind of just start mapping this out. Whoa, it's pretty big. Okay, so let me zoom out a little bit, and we'll say that this text right here, I love pizza, we'll just say that this ended up here in space. Again, it doesn't really matter exactly where, like up, down, left, or right. I just want to show you something real quick. So we'll say that this text, I love pizza, is in space right here. Now let's get another one of my comments. I need to work out more. And let's just make another shape for this. So this is I need to work out more. Now, the thing about vector embeddings, which make them very interesting, is this. If two pieces of text are similar, they're going to end up close to each other in this whatever dimensional space. Now, if these two pieces of text are not similar at all, they don't have any concepts, any words related, they're going to be far apart. So where would I really love pizza and I need to work out more be in relation to each other? My guess is that they're going to be pretty dang far apart. So we'll put them like this far apart. So let's keep going through our examples and do this one. I'm hungry. A big cheese pizza sounds great. Okay, so let me go ahead and add a little shape for this. And where would this be? I'm hungry. A big cheese pizza sounds great. So this is pretty closely related to pizza. Doesn't really have anything to do with working out. So I would put it like right around here, I would say. And we can just do one more for fun. Does anyone know a good book about Bitcoin? So, okay, let me just make the shape for this. Has nothing to do with pizza, nothing to do with working out really. So maybe it would just be like out here somewhere. Okay, so right now, if I was storing these embeddings or these vectors, then it would look something like this. Okay, interesting, but still not quite sure how this helps us with the pizza problem. Well, check this out. Now things are going to start coming together. Let's say that we have a chatbot and all of our previous messages are already indexed. They're already stored, and we'll take a look at exactly how to do that in just a bit. But they're stored in our data store, just like we're seeing right here. So now we got a new message that comes in and it says, I'm hungry. What kind of pizza should I eat? So imagine here we come in and we say, I'm hungry. What kind of pizza should I eat? Right now, ChatGPT or Aya, it doesn't have any context about our past. It doesn't know if I talked to it before, if I talked to it a million times before, and if so, what we talked about. It basically has no idea of any memory of me, and each message is like a brand new moment to it. But check this out. If I take this and I'm going to convert it to another shape, because what we're going to be doing with this message, the new one that comes in, is we're also going to be converting it to an embedding vector, just like we have been. And then let me just give this a different outline so you guys can see what's going on. Just outline it green or something. So this new message that comes in, once it gets converted to a vector, it's going to be placed somewhere in space. So then what we can do is we can say, okay, this is where you are. What we want to do from here is we want to go ahead and get the, I'll just say X nearest messages. And I say X because it could be like the 2 nearest ones, the 10 nearest ones. This depends on how you want to configure it. But let's just say we want to configure it to also get the 2 nearest messages. So that's going to be this one and this one. So this is going to be your original query that comes in, and these are going to be the 2 little bits of information that it found that is close to this message. So what we can do from here is we can take all of these messages and we can include it in the prompt. And then when we say, I'm kind of hungry, what kind of pizza should I eat? It's going to know that 1, I really love pizza, and 2, I particularly like cheese pizza right here. So with that, the desire is with this additional information, these additional memories, we can get a better response from the LLM. So sounds like a pretty cool concept. Now, how do we actually do this? Well, believe it or not, you cannot store these embedded vectors on Lucidchart. You have to use another data store. And one of the most popular ones is Pinecone. So with Pinecone, what you do is you first create an index. Now, an index is basically just like a big bucket or a data store that you can use to store vectors. And then once you have your index, you can pretty much just store vectors, and it's pretty simple actually. It's very simple actually. So let me go ahead. I already wrote a little bit of source code and I'll talk you through this. So this little example right here is going to be using OpenAI and Pinecone. Again, OpenAI is what we're going to be using to generate these vectors. And then we're going to be storing them in Pinecone, basically our database. So that's why I configured everything right here. And now here, what I'm doing is I'm just creating that index. I already have it created. As you guys can see, I just named it posts since it's going to store post vectors. And in this example, since I already have it created, I just commented this out. So, I don't want to create it again. It's already created. But then what I'm going to do, and again, this would probably be coming from an actual database, but because I didn't want to make this example too complicated, I just made a quick dict, and then I just gave it 10 random messages. The example that I'm going to be using eventually is I'm hungry, what kind of pizza should I eat? Same thing as we saw in Lucidchart. And I have 2 messages about pizza right here. I really love pizza, and I'm hungry, a big cheese pizza. I think that's the other one. Yeah. So hopefully, if everything works, we should be getting these 2 messages back. But either way, continuing on, what we're going to do next is I'm just looping through this messages dictionary. And for each of those messages or posts, I probably should have called it, what I'm going to do is I'm pretty much just going to generate a vector from it right here. And then once I have all those vectors or embedding vectors generated, I'm just going to insert them all into my post index right here. And that's how you see you have 10 matches or 10 posts in here because I had 10 matches. And another thing that I want to point out before I go any further, we'll get back to that code example in just a bit, is you see whenever I create this index, and maybe you didn't see I skimmed over this, but whenever I create this index, I need to explicitly say how big are the vectors that I'm going to be storing in it, because each vector has a set size. Whenever I use this function from OpenAI, it generates vectors in this size right here, 1536. Now, in this index, I can only store vectors with that size. And that's because of how the math works. You can't compare a vector, let's say, of a length of 3 to a vector of a length of 8. Whenever you're comparing vectors and getting the distance between them to find out how similar the text is, the vectors need to be the exact same size. So I just want to point that out. If you ever come across another function that can get you a vector and it's not compatible, just something to watch out for. But anyways, heading back to this example now. So what I did is I basically converted all my posts to vectors, and then I inserted them into my vector store, Pinecone. And now with this code right here is basically simulating what would happen whenever a new chat message came in. So I'm a user and I just typed, I'm hungry. What kind of pizza should I eat? Now, in order to find the most similar post related to this, I first need to convert. What the heck was that noise? Convert. I need to convert this to an embedding. Now, once I have that, I can pretty much use this query right here to say, okay, from this vector that I just created, basically a numerical representation of this string right here, get me the two nearest vectors. And then it actually doesn't return the string, it returns the ID, one of these numbers. So from the ID, all I have to do is pretty much just get the related messages from it. But if all this works, then what we should see is, actually let's run this right here. Let me bump this up a little bit so you guys can see. All right, look at this. So it printed out the two most closely related posts, and it was this one. It was the closest one. I am hungry. A big cheese pizza sounds great. And this one right here. I really love pizza. So there you go. What you would do from here is, of course, take this original question and these two other related ones and throw this into your prompt template. And then hopefully the LLM can come back with a much more tailored, accurate, memorable response. So yeah, that is it for this tutorial. I'm not exactly sure what we're going to be covering in the next one, but I'm sure that it's going to be awesome. So I will see you then.